Hi, I'm Mike Yon, coming to you once again from Hazelcast Studios with another installment of our web series, HazelVision. This time, we're taking a look at Hazelcast Jet, our high-performance, low-latency batch and stream processing engine. So what do we mean by stream processing? Stream processing simply means processing data as it is produced or received. Some common use cases for stream processing include credit card fraud detection, monitoring, Internet of Things sensors, or website clickstream processing. Stream processing is all about data in motion. It frequently involves analyzing or responding to real-world events as they're happening. Often, the analysis or response is of little or no value if it can't be delivered in a timely manner. So Jet is laser-focused on providing the ability to process high-volume event streams with very low latency. For example, we recently published a benchmark showing throughput of 1 billion events per second and being handled with less than 30 milliseconds of latency. There are multiple ways to describe the workflow of a Jet job. We'll look at the pipeline API today and its sequel in a future installment. Every pipeline must include a read-from stage to describe the initial data source and at least one write-to stage to describe the sink where data is written. Most pipelines will include additional transformational stages between these endpoints, but it's possible to create a simple data pump that just moves data from a source to a sink using only two stages. On this slide, we see the wide variety of connectors available, so a data pump might actually be something you find useful. At the left and right edges here, we see just a sampling of the different sources and sinks that Jet can connect to. Let's look at a very simple pipeline example. Here, I create a pipeline and then start it off as always with the read from. For our source, we'll use the item stream method of the included test sources class. This will give us a stream of simple events. We'll configure it to give us 10 events per second. Many things that we do in stream processing are time sensitive, such as aggregating data during specified windows of time. So often it's important to be aware of the event timestamp. In our simple example, this isn't a concern, so we omit them. For the first iteration of this example, we won't include any intermediate stages, but we'll go straight to the write-to terminal stage. For the sink, we'll use sinks.logger, which just writes the received items to standard out. To run this pipeline, we need to submit it to a Jet cluster. Rather than create an external Jet cluster, we can just create a simple single-node embedded cluster with this new Jet instance call. Then we wrap our pipeline into a job and submit it to the cluster. This will continue to run until we interrupt it. So let's start it running. We see Hazelcast Jet starts up, it receives the job and writes the DAG of the job to standard out, and then it continues logging the events as they're received. Let's add a simple filter to our pipeline. As we saw in the output, all of our events have a sequence number. Let's filter the stream to only process events with an even sequence. We do this by adding a filter stage and writing a simple lambda function to do the filtering. Now when we run the pipeline, we see that indeed we will only get items that have an even sequence number in our output. We can alter the pipeline again and add a mapping stage. This allows us to transform objects. Let's turn our simple event objects into strings and then upshift the string. We run this again. And now we see that our simple event descriptions have been upshifted. Let's wrap up, as usual, with some cluster facts. We've seen how we can start running Jet in embedded mode to get our development going quickly. As we need to scale up, we can offload Jet processing to a separate cluster and then scale it up as needed. We've used the pipeline API, first to build a simple data pump with just a source and a sink, and then we added a filter stage and a map stage into our basic pipeline. In future HazelVision installments, we'll look at additional capabilities, such as invoking external helpers written in Python or gRPC-supported languages that might include machine language inference. We'll look at using SQL to define Jet jobs. We'll look at how you can enrich the data stream with data from various sources. And we'll look at how you can update running Jet jobs without any loss of data. Thanks for tuning in to this episode of HazelVision. Feel free to contact us with comments or suggestions for future topics.